right, we are looking at our target 6.2 mastery learning objective. I can use the distance formula to calculate the perimeter of a figure on a coordinate plane. Okay, so yesterday we looked at our midpoint formula. Today we're going to be looking at our distance formula. So we need to know what the distance formula is. And we're going to write down this formula. You will never actually memorize it or use it probably in the way it looks. The distance formula equals, so whatever distance equals a huge, a big square root, and it is x2 minus x1 squared plus y2 minus y1 squared. Okay. That is our distance formula. It is actually just a reworking of Pythagorean's theorem. Okay? So remember, I'm going to do this on the side. Pythagorean theorem is a squared plus b squared equals c squared. If I take the square root of both sides, I have that big square root of a squared plus b squared, which equals c, right? That's our distance. So this x2 minus x1 is just a, and this is just b, and it matches that exactly. Okay, so I never really use the distance formula. I just think of it as Pythagorean theorem. Okay? And I'll show you how we do that. So that x2 minus x1, just as we looked at with partitioning a segment, is really what we call our x distance and our y distance. Okay? So between these 2 points, what's our x distance? Well, if I go from here to here in my x, I go over 2. You don't have to worry about units when you're talking about, positives or negatives when you're talking about distance. Okay? But you could say it's -2. You see why it doesn't really matter. My y distance, how far it goes up or down, well, 1, 2, 3, 4. Okay? Hey, look. It's now, this line has turned into a right triangle, and I can find my c. Okay. So, my a squared, and if you use negatives, make sure you put it in parentheses, that it's parentheses -2 squared, especially if you're typing it into a calculator. B is 4 squared. Alright, that's supposed to be blue. I'm already annoyed with this. Oh, sorry, guys. Equals c squared. So then we have -2 squared, which is -2 times -2, and a negative times a negative is a positive, so we get 4. That's why the sign doesn't really matter for distance. It's because it will always end up being positive in the end, because if you have a negative and a negative, it's a positive, or a positive and a positive. So it's up to you. Plus 4 squared is 16 equals c squared. And then 4 plus 16 is 20. When I take my square root, you cannot take the square root of 20. You can take the square root of 4, right? And 4 times 5. I'm going to move it over here. The square root of 4 then is 2. You can't take the square root of 5. So my distance here, the distance is 2 square root 5. We can approximate that. And I would just do the square root of 20 Because what if you did this wrong? So if you're typing in the calculator, just do what you originally had. Sorry, I keep going away with that. So 4.47. Okay, is this distance. So you can find any diagonal distance by using Pythagorean's theorem. Then we can use our distance formula to find perimeter. And what is perimeter? Perimeter is the total distance around a figure. So let's look at this first one. Find the perimeter of the triangle shown at the right. If your side goes straight up or down or straight across, you can just count. Right? This is easy. This side. 1, 2, 3, 4. So the length of EG, how we show with the distance, is we put the thing on top. Right? It's a line segment. So the line segment EG is 4 units long. Now I want to find EF. I'm going to start at E and find my X distance, right? It goes 1, 2, 3, 4, 5, 6. And my Y distance, 1, 2, 3. And hey, look, there's our triangle. We're always finding C in these ones. Right? We always have the 2 legs and are finding our hypotenuse. Alright? So I have 6 squared plus 3 squared equals C squared. Well, 6 squared is 36. 3 squared is 39. Is just 9. I'm going to say 39. We add these together. 36 plus 9 is 45. For perimeter, we're always going to approximate. And we do not have to simplify. So the square root of 45, which is 6.71. So that was E to F. I'm going to keep track of my sides over here. And then I have F to G, right? So again, my X distance is also 6, but my Y distance is simply 1. I'm going to do 6 squared plus 1 squared equals C squared. 36 plus 1. Adding these together, 36 plus 1 is 37. Square root both sides. And I'm going to throw that in my calculator. The square root of 37 is 6.08. So that was FG. So I'm going to add all of these up at the end, right? So that's why it's nice to kind of keep track on the side, and then you can just easily add them up. 1 and 8 is 9, 7, 10, 16. And then we just say units at the end. I don't know what the unit is, but each one of these boxes is 1 unit. Okay? So our total perimeter of this triangle is 16.79 units. Easy enough. Let's go ahead and look at the next page. Alright, so sometimes we'll have to draw our own figure. QRS has vertices of Q at 1, 2. R is at 4, 6. And S is at 5, 2. So same thing. Again, I like starting with the straight side. Q and S. It's just 1, 2, 3, 4 units. And then I'm going R and Q. Again, over, right, my X distance and then my Y distance. It goes over 1, 2, 3, and down 1, 2, 3, 4. So that's 3 squared plus 4 squared equals C squared. 9 plus 16. Adding these. This one's nice and easy. I can take the square root of 25. It's 5. Okay. So the distance from Q to R is 5. Then R and S, right? I'm going over 1, down 4. Same idea, 1 squared plus 4 squared equals C squared. Right? 1 squared is 1, 4 squared is 16. And then 1 plus 16 is 17. I will want to use my square root here. 4 point something. Oh, 17. Oh my gosh. Sorry. 4.12. Okay. So that was R to S. And then I'm going to add them all up. So the 2, the 1, 4 plus 5 is 9, plus 4 is 13. I am not using a calculator. You can feel free to use a calculator to add those up. Just doing them in my head quick. Okay. All right, moving on to example 4. Example 4 is actually easier. It has no diagonal. So I'm just going around and counting the straight lines. We just have to be very careful that we count all of them. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. One, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 1, 2, 3, 4, 5, 6. 2. 2. Now I'm just adding. So I have 7, 13, ooh, 14, 5, 9, numbers? 7, 8 numbers. Fabulous. Okay, so 7 plus 3 is 10, 14, 19, 28, 34, 36, 38. Bring the 8 down, carry the 3. 3 plus 1 is 5. 58 units. Again, some nice paper and pencil math. However, feel free to use a calculator for those. Alright, last example, example 5. Again, simply, it's just one where we have to draw our lovely picture. So it says quadrilateral ABCD has vertices A, negative 2, 1. So negative 2, 1 is where A is. B is at 3, 2. So I'm connecting the dots, right? C is at 2, negative 2. Connecting the dots. And D is at negative 2, negative 2. So I'll start by going from A to B, right? Or using that AB. The x distance is here. That's 1, 2, 3, 4, 5. My y distance is here. It's 1. So I have 5 squared plus 1 squared equals c squared. 5 squared is 25 plus 1. That's 26. And if I take the square roots, the square root of 26 is 5.10, right? I'm going to bump all that up. So that's A to B. If I look at this line, my x distance is 1. My y distance is 1, 2, 3, 4. So I have 1 squared plus 4 squared equals c squared. That's 1 plus 16. 17. We did this exact problem already. Still in my head there. The square root of 17 is 4.12. So that's B to C. C to D, I can just count. It's 1, 2, 3, 4. I don't have to do any Pythagorean theorem. And then same thing with D to A, it's 1, 2, 3. And my final step with perimeter is just adding them all up. 0 plus 2 is 2. Oh, no point yet. One plus 1 is 2, and then 5 plus 4 is 9, plus 4 is 13, plus 3 is 16. And always with pencil and paper math, feel free to use a calculator. So the perimeter of this figure here is 16.22 units. Okay, and that is it. I'll see you guys tomorrow.